This is SpaceTime, Series 27, Episode 108, for broadcast on the 6th of September 2024. Coming up on SpaceTime, how NASA changed an asteroid's orbit, construction continues on the new Lunar Gateway Space Station, and success for Blue Origin's 8th space tourism mission. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has confirmed that NASA's DART impactor mission permanently changed the orbit and shape of the asteroid Dimorphos. A report in the Planetary Science Journal shows that when NASA's Double Asteroid Redirection Test, or DART spacecraft, collided with Dimorphos in 2022, the tiny moon was significantly deformed, creating a large crater and reshaping it so dramatically that the moon derailed from its original evolutionary progression. The study's authors believe that Dimorphos may now start to tumble chaotically as it attempts to move back into gravitational equilibrium with its parent asteroid Didymos. The study's lead author, Derek Richardson from the University of Maryland, says that for the most part, the original pre-impact predictions of how DART would change the way Didymos and its moon move in space were correct. But there were some unexpected findings that are now helping to provide a better picture of how asteroids and other small bodies form and evolve over time. One of the biggest surprises was how much the impact of DART changed the shape of Dimorphos. According to Richardson, the asteroid moon was originally oblate in shape, sort of like a hamburger. But it became more prolate, stretched out like a football, following the DART spacecraft impact. Scientists were expecting Dimorphos to be prolate pre-impact simply because that's generally how they believe the central body of the moon would gradually accumulate material that had been shed off by a primary body like Didymos. It would naturally tend to form an elongated body that would always point its long axis towards the main body. But these results contradict that and indicate that something more complex is at work. Furthermore, the impact-induced change in Dimorphos' shape likely also changed how it interacts with Didymos. Richardson noted that although DART only hit the moon, Dimorphos and Didymos are connected through gravity. The debris scattered by the spacecraft on impact also played a role in the distributed equilibrium between the moon and its asteroid, shortening Dimorphos' orbit around Didymos. Interestingly, Didymos' shape has remained the same, a finding that indicates that the larger asteroid's body is firm and rigid enough to maintain its form even after losing mass to create its moon. According to Richardson, Dimorphos' changes have important implications for future exploration efforts, including the European Space Agency's follow-up Hera mission to the Dimorphos system, which is slated to launch next month. Originally, Dimorphos was probably in a very relaxed state, with one side permanently pointing towards Didymos, just like the Earth's moon always has the same face pointing towards our planet. But now it's been knocked out of alignment, which means that it may be wobbling back and forth in its orientation. In fact, Dimorphos may be tumbling, meaning the DART spacecraft may have caused it to rotate chaotically and unpredictably. The authors are now waiting to find out when the ejected debris will clear from the system, whether Dimorphos is still tumbling in space, and when it will eventually regain its previous stability. One of the biggest questions now is if Dimorphos is stable enough for a spacecraft to land on it and install research equipment. It could take 100 years to see a noticeable change in the system, but of course it's only been a few years since the impact. Learning how long it takes Dimorphos to regain stability will tell astronomers important things about its internal structure, which in turn will inform future attempts to deflect hazardous asteroids. By late 2026, Hera will arrive at the binary asteroid system containing Dimorphos and Didymos. It'll assess the internal properties of both asteroids for the first time, providing a more detailed analysis of the DART mission and its implications for the future. Richardson says DART gave science an insight into complicated gravitational physics that you simply can't do in a lab. And all of this research is helping astronomers calibrate future efforts to defend the Earth in the event of an actual asteroid threat. You see, like it or not, the bottom line is that there is a non-zero chance of an asteroid or comet hitting the Earth one day. It's not a question of if, it's a question of when and how bad that will be. This is SpaceTime. Still to come, construction continues on the new Lunar Gateway Space Station, and success for Blue Origin's 8th space tourism mission. All that and more still to come on SpaceTime. Humanity's first lunar space station is continuing to take shape, with the assembly and testing now underway of its core elements, the Power and Propulsion Element Module and the Habitation and Logistics Outpost Module. The Lunar Gateway Space Station will eventually be assembled in orbit around the Moon and serve as a jumping-off point for excursions down to the lunar surface. It'll serve as a science laboratory, a habitation module and a communication hub for astronauts as part of the Artemis program. Gateway will be deployed into a near-rectilinear halo orbit around the Moon, a Lagrangian L1 position where the gravitational pull of the Earth and the Moon cancel each other out. The eccentricity of this orbit takes the station to within 1,500 kilometres of the lunar North Pole surface at its closest approach, and as far away as 70,000 kilometres over the lunar South Pole every 7 Earth days. Gateway will be the first modular space station to be both human-rated and autonomously operated for most of the time, especially during its early years, as well as being the first deep space station far from low Earth orbit. Gateway will centre around its Power and Propulsion Element or PPE module, which will include solar arrays that generate power for the station and both chemical and ion electric propulsion systems. In fact, the PPE will use the largest rollout solar arrays ever built, together about the size of a football field end zone. The module itself is now being built by Maxar Space Systems in Palo Alto, California, under supervision of NASA's Glenn Research Center in Cleveland, Ohio. Meanwhile, Thales Alenia Space has been tasked with the job of building the hull for the Habitation and Logistics Outpost module. Final welding tasks and crucial stress testing has now been completed at its plant in Italy. The Habitation and Logistics Outpost Module, or HALO, will now travel to Gilbert, Arizona, where Northrop Grumman will complete the final fit-out. It'll then be launched into lunar orbit with Gateway's Power and Propulsion Element. Meanwhile, Thales Alenia Space has now started preliminary work on Gateway's Lunar International Habitat Module, on which it's the primary contractor for the European Space Agency. In addition to the PPE, HALO and the Lunar International Habitat Module, 2 more modules, one from ESA and one from MBR Space in the United Arab Emirates, are now under construction and will constitute the core modules of the new space station. Meanwhile, the Canadian Space Agency is building a new robotic arm for the station, the Canadarm3, and numerous scientific instruments. International teams of astronauts will expand Gateway with additional living and working modules. These will include the 4-ton Asteroid module. Asteroid stands for European System, providing refueling infrastructure and telecommunications. As the name suggests, it'll provide additional xenon and hydrazine fuel capacity, additional communications equipment, and an airlock for science packages. Then there's the US Utilization Module, a small pressurized space that would enable crews to board the space station on the very first mission to Gateway for the assembly sequence. It'll initially store additional food and will be launched alongside a Sprite. Next comes the Gateway Logistics Modules. They'll be used to refuel, resupply and provide logistics on board the space station, and it'll be equipped with a Canadian-built robotic arm. Finally, there'll be the Gateway Airlock Module. It'll be used to perform extravehicular activities outside the space station and to berth deep space transports. A number of lunar landing vehicles will also call Gateway home. These will shuttle between the orbiting outpost and the lunar surface, carrying crew and supplies. This is SpaceTime. Still to come, success for Blue Origin's 8th space tourism mission, and the September Equinox, the powerful Cygnus X1 X-ray source, and the Epsilon Perseids and Aurigids meteor showers are among the highlights of the September night skies on Skywatch. Blue Origin has successfully flown another 6 space tourists into the ultimate frontier. Mission NS-26 marked the 8th human spaceflight for the company and its New Shepard rocket, transporting people above the Kármán line, the internationally recognized boundary marking the edge of space, 328,000 feet or 100 kilometers above the Earth's surface.
Those aft fins moving back and forth. The gantry has retracted. These astronauts are going to space. Godspeed, New Shepard, and enjoy the flight, astronauts. See you when you get home.
Start. 2, 1.
And there she goes. New Shepard has cleared the tower on its way to space. With its crew of 6, they are screaming up towards the Kármán line. Those milestones. First one coming up here is Max Q. Max Q has been confirmed. Maximum dynamic pressure. It's when the forces on the vehicle between the atmosphere and the speed are at their maximum. We've punched right through it. As well as punched through that layer of clouds, the vehicle continues on its upward ascent towards space.
The launch from the company's West Texas complex went smoothly, with main engine cutoff and stage separation both occurring on time.
All right, main engine cutoff and separation have been confirmed. This is when our astronauts are feeling zero G. Dr. Rob Furl is going to start his experiments up there in the cabin.
Hopefully after a little time to look out the window.
Yeah,
pre-experimentation.
I would totally steal at least a couple of looks out of those big, gorgeous windows. The speed is reducing. When it hits 0, that is when we've hit apogee. At this point, we are well over the Kármán line, about 328,000 feet or 100 kilometers up.
The passenger capsule then continued climbing, eventually reaching an apogee of over 342,000 feet. That's more than 104 kilometers above the ground. As the spaceship soared beyond the Kármán line, passengers could see the curvature of the Earth and the thin blue line of the planet's life-giving atmosphere below the velvet blackness of space. They also had a few minutes to experience weightlessness, allowing them to float around the cabin before the capsule began its return to Earth.
Now, they're unbuckled at the moment. They're turning their somersaults. They are soaking it in. They are, we're witnessing 6 people having their minds blown right now as we speak.
Meanwhile, the booster was already on its descent back to the planet's surface, initiating a landing burn and briefly hovering over the landing pad before finally touching down.
But the booster is heading on down, and it will beat the capsule back to Earth. The booster, of course, has a controlled landing on a landing pad just 2 miles north of where it's taken off from. The capsule, less aerodynamically shaped, will land second under 3 parachutes in our landing zone in our valley in West Texas. So far, a nominal flight of our 26th mission to space and back of the New Shepard vehicle. All 6 astronauts are back in their seat, and the booster is screaming on home.
Yeah, as we mentioned, that booster is going to return to Earth a lot faster than the capsule because of the aerodynamic nature of the crew capsule.
We see the drag brakes have been deployed.
There's the relight of that BE-3 engine. That gorgeous hover above the landing pad. And booster touchdown, a successful touchdown of the booster for the NS-26 mission. Always a sight to see.
Always a sight to see. It's been going thousands of miles per hour, and then it comes in landing. You see it just kind of hovers there at 5 miles an hour. It's such a smooth descent and landing. As a reminder to people, this is so critical to the reusability, because the smoother the landing, the less you jostle the rocket, the less you have to refurbish the rocket, the more uses you can get out of the rocket.
Absolutely. And some really cool things here, right? Like those fins you were talking about earlier, our lessons learned with guiding this vehicle back are going to be applied to our next big vehicle, New Glenn. So again, just so many lessons learned from this booster every single mission.
Every single mission. Now, the crew capsule is obviously also coming back down to land here.
As the passenger capsule began its own return to Earth, it descended rapidly until drogue chutes released, followed by 3 blue and orange mains parachutes, which brought the spacecraft to a soft landing in the Texas desert just 3 kilometers from the launch pad.
We are going to have first the drogue parachutes that come out. Those are kind of like the guide parachutes. Then we're going to see the mains. They will reef So they're going to kind of go out just a little bit, and then they fully inflate. And talk about cutting speed.
And again, these parachutes, both the drogues and the mains, are essential in providing a gentle touchdown for the capsule. But as we get closer to the ground here, you're going to see a retro thrust system on the base of the capsule, which does kick up a bit of West Texas dust, but it makes for an even smoother touchdown than, again, like you said, the already slow speed that the capsule is descending at now. We're just 400 feet away from touchdown, and crew capsule touchdown. Welcome home to the newest 6 astronauts, the Blue Steel team. Once more, what appears to be a completely smooth flight for New Shepard. Our booster touching down at the landing pad, and a soft landing for our latest crew.
The total mission flight time was 11 minutes. Blue Origin doesn't disclose the cost of its tickets to space, but prices are believed to be around $250,000 per seat, although we're told William Shatner, aka Captain James Kirk from the Starship Enterprise, got to travel for free. Blue Origin's main competitor in the suborbital space tourism market, Virgin Galactic, is currently on a 2-year hiatus as they prepare their next generation of spaceplanes for service. This is SpaceTime. And time now to turn our eyes to the skies and check out the night skies for September on Skywatch. September was the 7th month of the year in the old Roman calendar, which had just 10 months. That's before the addition of January and February. That 10-month year is still reflected today in the name September or Septem, being Latin for 7, October or Octo meaning 8, November or Novem 9, and December or Deci meaning 10. It really wasn't until the Gregorian calendar that January the 1st marked the start of the new year, but in the beginning it was mostly only Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated the new year on March the 25th, marking the Feast of the Annunciation and Easter. The earliest recordings of a New Year celebration are believed to have taken place in Mesopotamia around 2000 BCE, around the time of the Northern Hemisphere vernal equinox in mid-March. A variety of other dates tied to the seasons are also used by various ancient cultures. The Egyptians, Phoenicians and Persians began their New Year off with the fall equinox, and the Greeks celebrated it on the winter solstice. While the Jewish New Year, or Rosh Hashanah, the Festival of Trumpets, occurs in September, where it marks the beginning of the Northern Hemisphere cycle of sowing, growth and harvest, and apparently the creation of Adam and Eve, according to the Jewish Bible, the Old Testament. The September equinox will take place at 10:43 on the evening of Sunday, September the 22nd, Australian Eastern Standard Time. That's 8:43 in the morning, US Eastern Daylight Time, and 12:43 in the afternoon, Greenwich Mean Time. The day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise exactly due east to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the word equinox is derived from the Latin, meaning equinus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun, and Earth's axial tilt is pointed to the same direction in the sky, regardless of Earth's orbital position around the Sun. So on other days of the year, either the northern or southern hemisphere are tilted more towards the Sun. But on the two equinoxes, around March the 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, it means the start of fall or autumn, while those of us south of the equator are moving into spring. Now, it's also worth noting that on geological timescales, the solstices and equinoxes change because of a process called precession, which causes Earth's spinning axis to wobble like the axle of a spinning top. The rate of precession is only about half a degree per century, so people don't notice it on human timescales. But because the direction of Earth's axis of rotation determines at which point in Earth's orbit the seasons occur, precession will cause a particular season to occur at a slightly different time from year to year over a 21,000-year cycle. Of course, as well as precession, the Earth's orbit itself is also subjected to small changes called perturbations. That's because Earth's orbit's an ellipse, and so there's a slow change in its orientation, which gradually shifts the point of perihelion, Earth's closest orbital position to the Sun. Now, these two effects, the precession of the axis of rotation and the change in the orbit's orientation, work together to shift the seasons with respect to perihelion. And because we use a calendar year that's aligned to the occurrence of the seasons, the date of perihelion will gradually regress through this 21,000-year cycle, unless we compensate for it. Okay, let's start our tour of the September night skies by looking towards the east and the constellation of Capricornus, the goat. The name comes from the ancient Greek tale about the demon Typhon emerging from a fissure in the earth and attacking Zeus, the king of gods, during a banquet. The sudden appearance of Typhon scared Pan, the flute-playing goat boy, who tried to escape by turning into a fish and swimming away. However, he realized his cowardice before completing the transformation, and so distracted the demon by playing his flute instead. And this gave Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both cowardly and brave, Zeus placed Pan in the sky forevermore, still in his half-goat, half-fish guise. The brightest star in Capricornus is Delta Capricorni, also known as Deneb Algedi, or the tail of the goat. It's a near neighbour, located just 39 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum, and the ultimate speed limit across the universe. Deneb Algedi is a spectral type A white beta Lyra variable eclipsing binary. It's comprised of two stars closely orbiting each other. Now, astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our sun fits in, then there's spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red dwarf stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun is officially classified as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are usually about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As we mentioned earlier, Deneb Algedi is a beta Lyra variable eclipsing binary system. It's made up of two stars closely orbiting each other. The total brightness of the system changes because the two component stars periodically pass in front of each other as seen from Earth, thereby blocking out the light from the other star in the system. The two component stars of beta Lyra systems are usually massive giants or supergiants, so close to each other that their shapes are heavily distorted by their mutual gravitational forces. This gives each of the stars in the system an ellipsoidal shape with extensive mass flows from one component to the other. Just below Capricornus on the eastern horizon, you'll see the constellation Aquarius, the water carrier to the gods. Greek mythology describes Aquarius as the most beautiful-looking boy that ever lived, and so was carried from Earth up to Mount Olympus by Zeus in the guise of Aquila the eagle to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once spectral type B blue-white stars. The pair are moving through space perpendicular to the plane of the Milky Way galaxy. Beta Aquarii, the brightest of the pair, is also known as Sedal Sud. It's a multiple star system, located about 540 light-years away. The primary star is about 6 times the mass of the Sun, but emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of our Sun. Beta Aquarii appears to have at least 2 faint companion stars, but you'll need a decent-sized telescope to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Sedal Melik. It's about 520 light-years away, around 6.5 times as massive as the Sun, and some 3,000 times as luminous. Next, we move to the southern constellation of Perseids Austrinus, the Southern Fish. The brightest star in the constellation is Fomalhaut, the mouth of the Southern Fish, and the 18th brightest star in the night sky. Interestingly, thousands of years ago, it was used to mark the position of the winter solstice, the Sun's most southerly position as seen from the northern hemisphere. But the precession of the equinoxes, which we talked about earlier, has now moved the northern winter solstice to its new position in December. Located only 25 light-years away, Fomalhaut is a spectral type A white-yellow star, about twice the mass of the Sun and around 16 times as luminous. It's also a really young star, only about 400 million years old. By comparison, our own star, the Sun, is some 4.6 billion years of age. Fomalhaut exhibits an excess of infrared radiation, indicating that it's surrounded by a circumstellar disk. It's also part of a triple star system, together with a spectral type K orange dwarf star TW Pisces Austrini and a spectral type M red dwarf star LP 876-10. Turning to the north now, there you'll see the constellation Pegasus, the winged horse of Greek mythology. Pegasus is the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to become the bearer of thunder and lightning bolts for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's bloated out to a spectral type K supergiant nearing the end of its life. Astronomers are still debating as to whether it will end its days as a core collapse supernova or a rare neon oxygen white dwarf. Also in the north is the constellation Cygnus the Swan, which lies on the plane of the Milky Way galaxy. Cygnus contains the star Deneb, one of the brightest stars in the night sky and one of the corners of the summer triangle. It's also home to the giant Cygnus OB2 stellar association, which includes one of the largest known stars in the universe, MNL Cygni, a red hypergiant, about 1,183 times the radius and 50 times the mass of our Sun. In fact, were it placed at the centre of our solar system where the Sun is, its surface would extend out beyond the orbit of Jupiter. It's so big it contains a volume approximately 1.6 billion times that of the Sun. NML Cygni is located about 5,300 light-years away. Now, Cygnus is also home to Cygnus X1, a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered back in 1964, and even today it remains one of the most studied astronomical objects in the sky. The black hole is estimated to have about 14.8 times the mass of our Sun, all crammed into an event horizon with a radius of just 44 kilometres. Little wonder black holes are the densest objects in the universe. Located just above the northern horizon this time of the year is the star Vega. It's the brightest star in the constellation Lyra and the 5th brightest star in the night sky. Vega has about twice the mass of our Sun. And it's a relatively young star, less than 500 million years old, and it's also fairly close, just 25 light-years away. Now, once again, due to the precession of Earth's rotational axis, Vega used to be the northern pole star around 14,000 years ago, and it will do so again in another 12,000 years' time. Just above Vega is Alpha Aquila or Altair, the brightest star in the constellation Aquila. It's a spectral type A white-yellow star with about twice the mass of our Sun. Altair is located really nearby, just 16.7 light-years away, and it rotates very rapidly, with an equatorial velocity of about 286 kilometers per second, and that's a significant fraction of the star's estimated breakup speed of around 400 kilometers per second. Now, this high rotation rate means Altair isn't spherical, but highly flattened at the poles. Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water bearer for the gods. Looking to the southeast now, and you'll see the bright star Achernar. It's the brightest star of the constellation Eridanus, the river. Located around 140 light-years away, Achernar has 7 times the mass and 3,000 times the luminosity of our Sun. The star rotates so rapidly it's elliptical in shape, with its equatorial diameter being about 56% wider than its polar diameter. September also sees the bulk of the Aurigids meteor shower, which is produced as the Earth passes through the debris trail left by the comet KESS C1911N1. KESS is a long-period comet, only reaching the inner solar system every 1800 to 2000 years. Its meteor shower runs between August the 28th and September the 5th. The Aurigids provide up to 5 swift and bright meteors an hour, with its peak just before dawn on September the 1st. It's best viewed from the northern hemisphere as its radiant, that is, the direction the meteors appear to be coming from, lies in the northern sky constellation of Central Auriga. A second meteor shower in the month of September is the Epsilon Perseids, which run from September the 5th to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus or Algol. Now, the Epsilon Perseids should be confused with last month's Perseids meteor shower. That's because while both appear to have their radiant in the constellation Perseus, they're caused by debris trails from 2 very different comets. And now with more on the September night skies, we're joined by Jonathan Nally from Sky and Telescope magazine.
G'day, Stuart. Well, yeah, September, this is a good time of year actually for stargazing, particularly for where I live, south of the equator in Australia, because we've got some really good constellations to see down here this time of year. Look, we've got the sort of the winter constellations are still up nice and high during the evening time, but when the morning hours come around, we've got the summer constellations, the southern summer constellations are starting to make their appearance in the morning sky. So in the mid-evening, we've got the Milky Way, of course, that's our home galaxy seen from the inside, and it's stretching right across the sky from north to south. You can't miss it if you've got dark enough skies. If you're in the city, like where I live in the city, you just can't see it. You don't even notice it because there's so much light pollution. But if you can get away from the lights a bit, somewhere dark, you will see the Milky Way. That's our galaxy seen from the inside. It's just magnificent. It's beautiful. So for us down here, we've got the centre of the galaxy and the star fields of Scorpius and Sagittarius are more or less directly overhead from the sort of mid-southern latitudes around 30, 40 degrees south. And this region is really great to view with small telescope or binoculars, but do try and get away from sources of light pollution. Don't go and stand outside or underneath a street light or something like that. And do give your eyes time to get dark adapted too. Even if you do live in a dark spot or you're visiting a dark spot or whatever, if you've been inside with the lights on, when you go outside, you've got to allow your eyes at least 20 minutes or so at least to get dark adapted to be able to see the faint stuff.
And put some red cellophane on your torch or something like that if you're going to use it to read anything.
Yeah, try and avoid a torch, but or a flashlight as the Americans will call them, but if you do have to use one, then try and dim it down if you can, or put something red over it to, actually orange apparently is meant to be better than red.
Oh, that's what we use on aircraft, yeah. When I was flying, all the controls at night were in orange, yeah.
Amber, yes. Even some of the sort of computerized telescope controls you can get these days, they've got more of an ambery sort of tinge to them than what you would call bright red. But anyhow, yeah, look, if you're going to go outside, let your eyes get dark adapted, and yeah, try not to use a torch if you can. But if you have to, just very, very briefly, and don't shine it directly into your eyes. But look, you can spend hours and hours out there just sweeping back and forth through Scorpius and Sagittarius, this sort of central part of our Milky Way. There's so much to see, endless lists of famous deep sky objects like Lagoon Nebula or Trifid Nebula, the Eagle Nebula, that sort of thing. Is just stacks of it there. Way down to the south from where I am, you've got the Southern Cross. It's flying on its right-hand side at the moment. You've got the 2 pointer stars, these 2 bright stars above it. And if you have really dark skies, and you've let your eyes adapt to the dark, see if you can spot a big dark patch just next to the Southern Cross. This is a huge cloud of interstellar dust and gas floating out there in space, and it's been for years now called the coal sack for obvious reasons, this big dark patch in the Milky Way. It's not a hole in the Milky Way, it's just a big blob of gas and dust blocking the stars from behind it. It's actually really nice. And while we're still in the area of the cross, the left-hand star of the cross is sort of kite shape. The left-hand star of the kite shape, at the moment, that's the one that's uppermost in the sky. There's a little cluster of stars just beside it. That's called the Jewel box cluster, the Jewel. A small telescope or even a pair of binoculars will show it really well. It's very pretty. It's got a variety of different coloured stars in it. Now, as the night goes on, the Earth's turning, the stars are going down in the west, and they're coming up in the east. And the eastern part of the sky will actually seem a bit bare through the latter part of the evening, right through to about 1 a.m., 2 a.m. or so. But then you've got the mighty constellation of Orion, the Hunter, coming up above the horizon. So for astronomers in the southern hemisphere, this means that the summer is on its way. For our friends in the northern part of the planet, it means that winter is on its way. So Orion is, like many times about Orion, it's just so easy to see, so easy to spot with its trio of stars making up the Hunter's belt. And you've got the blue star Rigel on one side of the belt, you've got the red star Betelgeuse on the other side of the belt. They're quite bright, those two stars. Nearby to Orion, right next door basically, you've got the constellation Taurus, which has a very noticeable and easy to spot wedge-shaped cluster of stars called the Hyades, and it's got a bright red star called Aldebaran. I'll come back to that in a sec, because we're just going to talk about the planets now. So let's look at where the planets are, what we can see. In the early morning hours, you've got Jupiter, which is rising in the east around about 1:30 a.m. or so at the start of the month, and it's followed about 45 minutes later by Mars. Now, the two of them together are going to be a really, really good sight. They're probably about, I think it's about 8 degrees apart. The moon is about half a degree wide, so 8 degrees apart is about 16 moon widths apart. But you should notice them because they're both quite bright. But one interesting thing to do will be to compare Mars and two of those stars I just mentioned, Betelgeuse and Aldebaran, because all three of them are in the same part of the sky at the moment, and all three of them are red. And Aldebaran and Mars are pretty close to the same brightness, but Betelgeuse is a little bit brighter. So they're going to form a triangle. See if you can spot them, Betelgeuse and Aldebaran the stars, and Mars the planet. You'll be able to work out which one's Mars because from night to night you'll see that it will have moved a little bit in the sky, or will appeared at least to have moved a little bit in the sky as our line of sight is changing as both it and the Earth are travelling around the sun. So that's in the morning hours after 1:30, 2:30, 3 o'clock, that kind of thing, if you're up late or you're getting up early. In the evening sky, we've got two bright planets that are easy to see after sunset. The first is Venus, which is visible above the western horizon after the sun's gone down. You cannot miss it. You simply cannot miss Venus because other than the moon, it's the brightest thing you're going to see in that part of the sky.
And it's not actually a flying saucer.
No, it's not a flying saucer. You know, people sometimes they look up and see this bright thing in the sky and think, that wasn't there last night. What's that bright light? Fact is, it was there last night. You just didn't notice it, or it was behind a cloud or whatever, or it had already gone down by the time you went out to have a look. But it's going to hang around for quite a while.
It's amazing how often they tell you that it's not Venus. No, this was different to Venus. And then you ask them, well, say you saw Venus next to it, did you? And then there's this long pause.
Yeah. Or when you show them the evidence that it actually was Venus, it's disappointing. People want to see things in the night sky. They get a bit annoyed when the explanation is prosaic. Anyhow, so it's big and bright. You'll be able to see actually Venus and the moon close together. They're only going to be about 1.5 degrees apart. That's about 6 moon widths. So that'll be really nice to see. Now, the other star of the show this month is Saturn, and it probably really is the star of the show because Saturn is reaching opposition on the night of September the 7th or the 8th, depending on which time zone you're in. Now, opposition is when a planet and the sun are in opposite directions as seen from here on Earth. Right? So this means that when the planet is rising in the east as the Earth's turning, the sun is setting in the west. So they're 180 degrees apart, you know. So that's opposition. They're opposite each other. The good thing about this is that it gives you all night to have a look at the planet because, sometimes if a planet, like I mentioned before, so Jupiter is rising at 1:30 a.m. So you've got to get up early and go out and have a look at it, and you've only got it until sunrise. So, 5-6 hours or something like that. Whereas when a planet is at opposition, it's coming up just as the sun is setting, so you've got all night to go out there and have a look at it. And the best time to see a planet is when it's up nice and high, when it's highest in the sky, because then you're looking through the least amount of Earth's atmosphere just to get it. Because the Earth's atmosphere makes things flicker and wobble, and you might have dust or smoke in the way or anything, those sorts of things. So you want to get the planet up nice and high. So opposition, great time to see any of the outer planets. In this case, it is Saturn. And you'll find it really easily. Just go out after sunset, look to the east, and you can't miss it. It's fairly bright, and it has a yellowish tinge. And if you have a small telescope, or someone's got a small telescope, get it out and have a look, because you will be able to see Saturn's rings, which look really quite amazing, even through just a small telescope. And that, Stuart, is the night sky for September.
That's Jonathan Nally from Sky and Telescope magazine. And this is SpaceTime. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.